Okay. So, second part ng video natin, first problem. So, yung first problem natin is ang situation ulit, wala tayong presence ng permeability, wala tayong presence ng seepage, so therefore, yung water natin is static. Ngayon, given ang mga layers, meron tayong layer 1 na sand, wherein meron tayong specific gravity na 2.68 and void ratio na 0.6. Wherein, next natin, meron tayong second layer ng clay, wherein meron tayong specific gravity na 2.72 and void ratio na 0.9. And then last layer natin is an impermeable layer, which means that wala tayong seepage ng water downward. Ngayon, to analyze, meron tayong 4 points na kailangan. So, please refer to your handouts. Meron tayong 4 points na kailangan i-consider. And from point A to point D, kailangan daw nating hanapin yung normal stress or yung total stress, yung effective stress, and yung neutral stress. Okay. So, paano natin gagawin yun? So, from point A to point B, or point D, rather, delta, kailangan nating alamin ano ba yung total stress, yung neutral stress, and effective stress. So, madaling presentation yan is to create a table for that. Ngayon, yung total stress, alam natin kung paano, yung neutral stress or yung pore water pressure, and yung effective stress, wherein the effective stress is equal to the total stress minus the neutral stress. Now, pwede natin gawin ngayon is isa-isahin natin kung ano na yung mga stresses na present. So, at point A, just above the soil, pwede natin ngayon excuse me. So, pwede natin gawin ngayon is to determine ano ba yung stress. Since nandun lang siya sa line, sa surface natin, everything above a point of reference should be considered daw. Is there anything above point A? Wala. So, therefore, the total stress is equal to 0. In terms of neutral stress, meron ba tayong water above point A? Wala rin. So, therefore, 0 rin yung neutral stress. Therefore, effective stress is also equal to 0. So, there's none, particularly none at point A. Next, at point B. Point B is 2 meters below point A or below the ground surface, meaning to say, meron ng 2 meters thick na sand layer above point B. So, paano ba natin hahanapin yung total stress? Alam natin na yung total stress is equal to the unit weight of anything above multiplied by the height. Ngayon, doon sa total stress, pwede nating sabihin na yung unit weight na gagamitin natin is yung unit weight ng sand. Pero, ano ba yung gagamitin natin para sa unit weight ng sand? Ano ulit yung reference natin para makuha yung unit weight ng sand? Ano ba yung special capability or non-capability ng sand? Alam natin na hindi siya nakakapag-hold ng water. Therefore, kailangan nating gamitin na yung dry unit weight ng sand para doon sa first layer natin. So, in dry unit weight, ang given natin ay specific gravity na 2.68 and void ratio na 0.6. Ano ngayon yung formula natin for dry unit weight? Ang formula natin for dry unit weight ay equal to, specific gravity multiplied by the unit weight of water all over 1 plus E. Ganun lang siya kasimple. So, meron tayong specific gravity na 2.68 multiplied by the unit weight of water all over 1 plus 0.6. Ang dry unit weight natin ngayon ay equal to ilan? Okay. So, meron tayong 2.68 times 9.81 divided by 1.6. So, ang unit weight natin is equal to 16.432 kilonewton per cubic meter. Okay? So, kung meron na tayong dry unit weight, pwede na natin kuhanin yung total stress at point B. Paano natin kukuhanin yung total stress at point B? So, at point B, meron tayong gamma multiplied by height. Wherein, meron tayong 16.432 multiplied by 2. Or, equal to ilan? So, 16. Meron tayong 16.432. Sorry, doon sa group chat na lumabas. So, 16.432 times 2. Meron tayong 32.864. Next, meron ba tayong neutral stress na present at point B? Or meron ba tayong presence of water at point B? At point B, wala tayong presence of water, therefore, 0 lang yung neutral stress at point B. Ngayon, since 0 yung neutral stress or your pore water pressure, we can actually say, or we can actually tell that the effective stress is also equal to 32.864 since walang presence ng water. Okay? So, next natin, at point C. At point C, it is 2 meters below point B. Ibig sabihin, anything that is above point C must be considered. So, at point C, nasa sand layer pa rin siya, pero point C is above point B. Therefore, yung effect ng point B, pwede natin i-add. So, this is 32.864 plus. Ano ngayon yung kailangan natin i-add? I-add natin sa point C ngayon is yung effect ng 2 meters ulit. So, meron tayong 16.432 multiplied by 2 or equal to ilan ngayon? So, plus 32.864 ulit, meron tayong 65.728. Okay? So, at point C nandoon siya sa line ng water level natin. Pero since nandun siya sa water level mismo, meron bang water above point C? Wala. So therefore, 0 pa rin yung value ng neutral stress natin or ng pore water pressure. Which means that the effective stress is also equal to 65.728 kilopascal. So everything is in kilopascal. Ngayon, kung meron na tayong idea kung ano yung points B and C, pwede na rin natin makuha agad yung point D. Pero, take in consideration na the second layer is clay. At the same time, it is submerged in water. So, therefore, kung kukuha tayo ng unit weight para sa clay, yung unit weight ng clay natin ngayon is, saturated unit weight. Or, pwede nating sabihin na kung meron tayong present na specific gravity na equal to 2.72 and void ratio na equal to 0.9, we can say na yung saturated unit weight ay equal to, GS multiplied by Okay, so pag nagbubura, yan, para medyo malinis. Okay, meron tayong specific gravity plus yung void ratio multiplied by the unit weight of water all over 1 plus E. So therefore, meron tayong 2.72 plus 0.9 multiplied by the unit weight of water na 9.81 all over 1 plus E natin ulit na 0.9. Okay. So, bakit nga ulit natin inad yung 0.9? Since ina-assume natin na yung voids ay completely occupied by water, so therefore, kailangan nating isolve yung unit weight by using the whole void ratio para makuha natin kung ano ba yung capacity ng water within doon sa voids natin. Okay. So, kung isa-solve natin uli yan, balik natin uli yung calculator natin. So, meron tayong 2.72 plus 0.9 times 9.81 divided by 1.9. So, ang unit weight natin is equal to 18.691 kilonewton per cubic meter. Okay. So, kung meron tayo 18.691, we can say that the total stress is equal to, okay, so anything above point D must be considered. Therefore, if anything above point D should be considered, we must consider the effect at point C, which is equal to 65.728 plus. So, above point D, meron tayo 8 meters sa clay layer. So, therefore, this is equal to 18.691 multiplied by 8. So, at point D, meron tayong 65.728 plus 18.691 times 8. Meron tayong 215.256 kilopascal at point D for total stress. Okay, neutral stress. So, meron tayo 8 meters na water level above point D. So, therefore, pwede na natin ngayon kuhanin yung effect ng water by using the unit weight of water and the height of the water level above the point of consideration. Meaning to say, meron tayong 9.81 multiplied by 8 or 78.48 kilopascal pressure at point D. So, ibig sabihin, yung effective stress ngayon is the difference between total and neutral, which is equal to 215.256 minus 78.48 or equal to ilan? So, meron tayong 215.256 minus 78.48. So, the effective stress is equal to 136.776 kilopascal. So, for problem 1, ito na ngayon yung final answer. Okay? So, yung questions natin, sa comment lang ng post. Okay, so yung next video natin, yung derivation for C pages. Upward and downward.